So good morning. This is functions. Please make sure that you have the handout in front of you. And if you don't have it, go and get it. And this is what the two handouts look like. We're going to go through 5 different functions that Visual Basic provides. Those 5 functions allow you to do a variety of tasks very quickly. The first one that I'm going to show you, it's str $, string $, or str $. What it does is it takes a number and it turns it into a string. You'll notice that I've also got 2 green boxes up there. The first one, it says integers, singles, doubles, longs are all automatically converted to strings when they're concatenated. Remember how we just learned about the ampersand? When you use the ampersand with a numeric value, it will automatically convert it to a string. Str $, all it is you specifically telling the program, I want you to convert this number to a string. Sometimes you need it, sometimes you don't. And the word we use is explicit. That means you are giving a specific instruction. Take a look at the code snippet that I've got here. First, I've got x is assigned 5. We start off by having x being 5. Then I'm going to create my message, and to message I assign the answer is, which is a string, and then I turn my number into a string. I turn my x variable into a string, str $, and I concatenate the exclamation mark. In this case, the use of str $, is a little bit redundant. However, I do insist that you use it. And at the end, we display the message. You have not yet learned how to use message box, but it's a very easy way of showing a message, a string output to the user. The second function is called val string. It takes the value of a string and it gives you the numeric value. If string contains a number, it will give you a numeric value. So this slide shows you a few things about val. You've had a chance to copy it down by this point. So first of all, in the green box, notice val, it strips away all spaces and tabs. If you enter a space into a string, val ignores it. It also stops reading the string as soon as it finds a character that it cannot recognize as a number. So the letter G is not part of any decimal numbering system that we're aware of, so G would have to be rejected. And over here on the right, we've got 3 points. The first is that val turns a string into a number. The second is if you give val a string that isn't a number, what it gives you is 0. This is a strength and a weakness. What it means is you can't rely on val telling you that the string is not a number. We actually have a specific function that will test to see whether a string is a number, but we don't introduce you to that yet. Right now we're sticking with val. This works. So what I'm trying to tell you is you can't be sure if your string is 0 or if your string isn't a number, but that's okay. And then finally, remember that E notation is considered numeric. Val is capable of taking E notation and converting it into a numeric value. Here I have a number of examples. They match up with your sheet. I think there might be a few extras, so you may feel compelled to copy down the last few. In the case of val of 645.23, that is pretty straightforward. it will convert to 645.23. The next one, 22 Acacia Ave. It recognizes 22, and then it stops. It recognizes 22. It sees the space, and then it stops at the A, where it can't figure out what's going on. So you end up with 22. Val of 7. What do you think this is going to be? 7. Nice try. 0. It obviously is not anything numeric. Sure, a human could recognize that as something with numeric information in it, but it's not a number per se. The val of 198 43rd Street. I'd like you to take a moment and try to predict what is going to come out. Yes, and it ignores the spaces. So it strips the leading spaces, and it ignores the space between 198 and 43 to give you 19,843. The next one, the val of an empty string is 0. The val of 0 is 0. The val of 729 East 49th Street. What do we think that's going to be?
72,949.
Well, the E counts as to the power of 10. It is going to be the E notation. So Val can recognize this as 729 East 49th Street. And now that I look at it, I missed the quotation marks. Oops, my apologies. So that would be a syntax error. Let's pretend they're in there for now. So this actually would give you a very large number to come out. And the last one, 729, is what you would get because W is not part of E notation. Now for the third function. The third function involves a number line, and it is int. It's an interesting function. What it does is it returns the largest integer less than or equal to the number. One thing that will catch people off guard is negative numbers. Pay close attention to the examples on the next slide for the negative numbers. Here I've got my examples. I believe you may not have the last two. Is that right? Yeah. Oh, you do? Oh, you've got all of these. Perfect. I've got a number line here at the top. The examples on the side. We are going to go through the examples. Our first one, 4.2. You'll notice the circle that appeared on the number line. That represents 4.2. When we apply the function int to it, we end up with the value 4. Notice how it goes back to the next smallest integer. 3.7. It's appeared on the number line. And notice what's going to happen when we apply int to it. We end up with 3, and it goes back to the next lowest integer, or next highest lowest integer. The highest integer that's lower than the current value. We can do the same with 0.97. Very close to 1. If we were rounding, it would round up to 1, but we're not rounding. We are applying int to it. It goes down to 0. -3.6. This is what catches people off guard if they don't think about the number line. You can follow closely what's going to happen. It's going to go down to -4. It makes perfect sense when you look at the number line. However, Many of you will make the mistake of going up to -3 because you're thinking towards 0, towards 0, towards 0. That's what seems to get into some people's minds, but that's not it. It is not towards 0. It's towards the next lowest integer. -1.2 has appeared on the number line. It will go down to -2. And then we've got some additional examples. 18.9999999 will give you 18, and -99.7, -100. Any questions at this point? In this case, it's a matter of figuring out that one simple rule and remembering that you are working with the number line. If you can remember to work with the number line, you will be able to visualize this very nicely in your head. In terms of the number line, you can think of it always going to the left on the number line. The fourth one, finding the square root of a number. Quite straightforward. Sqr of a number returns the square root of a number. There is only one restriction. You can't have a negative number because you can't take the square root of a negative number. We have 3 examples. The square root of 49 is 7. The square root of 27.04 is 5.2. I would be impressed if anybody could get that one without the aid of a calculator. The square root of -25, error. The final function is the absolute number function. It returns the absolute value of the number given to it. And in case you've forgotten what an absolute number is, it's the magnitude of a real number without regard to its sign. So what exactly is absolute? It's merely the numeric value without the sign. So for example, ABS of 9 is 9. The absolute value of -5 is 5, because we ditched the negative sign. The absolute value of 0 is 0. Here you have the 3 possible inputs. There is nothing else inside the real number system that you can give to ABS. That's it. We only need 3 examples to cover all bases. So the last thing we're going to do is combine functions. The first function takes the square root of the absolute value of these exponents. So we've got a difference of squares, and our difference of squares is 64 subtract 100. 64 subtract 100 is -36. We're not concerned about the -36 because it becomes +36 through the ABS function. Then we can take the square root of 36 to give us 6. So here you can see that you can combine multiple functions to accomplish something. A second example, and you will also see this on an evaluation at some point, and in fact, just so you know, you won't be getting calculators on your tests. So you may very well get this kind of question on your test, and you cannot use a calculator. The reason for that is, I don't need to know decimals. We take the int of the square root of 79. So you ask, how can we possibly do that? Well, first of all, it's going to be the int of 8 point something. I don't exactly know what the decimal is. I don't care what the decimal is because the int takes my value and it returns the next lowest integer. So I get 8 out. Now let's take a look at the details of that particular question. You know a few things. The first thing you know is that the square root of 64 will be less than the square root of 79, which will be less than the square root of 81. You also know that the square root of 64 is 8. By now, I hope you've learned your basic square roots. You also know that the square root of 81 is 9. So, you can infer that the square root of 79 has to be greater than 8, and it has to be less than 9. Greater than 8, less than 9. If you apply int to that, you will get 8. Yes?
On a test, would you have to show the blue writing?
On a test, would you have to show all of this blue writing? No, you would not. I would basically expect you to write what you see here in black. That would be as much as I need. What I would recommend, if you don't already know them, is to memorize the first 5 or 6 more advanced square roots. So I presume that everybody knows square root of 1, square root of 4, square root of 9, square root of 16. Take a moment, memorize these if you haven't. Now this is the end of functions. At this point you will get practice sheets for functions. For the most part, you shouldn't run into problems. The one thing that I do see causing people confusion is the int function. So do pay attention to all of the questions that relate to int, especially if you find working outside of a number line confusing. So try to focus on how to use the number line to solve int type questions.